Hey gang, in this video we will explore a key pattern in the signs of trig ratios based on the quadrant through which their terminal arms pass. This pattern is summarized in a rule called cast rule and will be helpful to you when you solve trig equations. So here I have the unit circle, and what I also have here is I've set up the three ratios, cosine, sine, and tan. Right now my terminal arm intersects the unit circle at 1, 0. And as you know from your previous studies of the unit circle, the x-coordinate at that point represents the cosine of the angle 0, and the y-coordinate represents the sine of that angle 0. So as I move through the first quadrant, the points change, and my cosine, sine, and tan also change. Now I've set up the tan to be equal to the y-coordinate divided by the x-coordinate, because tan is, after all, the opposite side divided by the adjacent side. Okay, and so what you see here in quadrant 1, is that all three ratios are always positive, right? Which makes sense because x and y are always positive. Once I move into quadrant 2, however, you will notice that now only one of those three primary ratios is positive. Okay, so no matter where I go, cosine and tan will always be negative, and sine is the only one that's positive. Okay, moving forward through third quadrant, again, we have only one of those three ratios as being positive all the time. This time tan takes its turn being positive, and every other ratio is negative. And then moving into quadrant 4, it is now cosine's turn to be positive, and the other two ratios, sine and tan, to be negative. And so we come by this rule called cast rule because in this quadrant that I'm in right now, in the fourth quadrant, cosine is the only one that's positive. So maybe we could give this particular quadrant the letter C, right? Whereas in quadrant 1, all three of them are positive, right? So we'll give this quadrant the letter A for all, right? And in this quadrant 2, only sine is positive, so we'll assign the letter S to this quadrant. And in quadrant 3, tan is the only one that's positive, so quadrant 3 gets the letter T. So at the end of the day, we have a C, an A, an S, and a T assigned to specific quadrants, and of course cast is a nice little way to remember that. Okay, so now cast rule works for the primary trig ratios, but what happens if I were to add, say, the corresponding reciprocal trig ratio? So we've got sec A, we've got cosec A, and we've got cotangent A. Okay, so what I have now, if I can just barely get this on the screen here, is as I go through, let's start with quadrant 1 again, you can see that they're still all positive. Okay, every single one of these ratios is positive. As I move to quadrant 2, and remember quadrant 2 had the letter S assigned to it, so sine is positive, but we do actually end up with another positive, and that's cosecant A. Okay, that's actually no surprise because cosecant A is the reciprocal of sine A, and the reciprocal of a positive number is also going to be positive. The reciprocal of a negative number is still going to stay negative. Okay, so technically, cast rule works for the primary ratios, but technically there's another ratio, the corresponding reciprocal ratio, that's also positive, right? So if you remember in quadrant 3, we assigned the letter T because tan is positive, but in fact not only tan, but cotangent is also positive, and I'll show you that it is in fact positive there. And then if we move into quadrant 4, we assign the letter C here because cosine's positive, but the reciprocal of cosine is secant, so you can see that both cosine and secant are positive. And while we're here, I'll show you one other pattern here, and that's at the quadrantal angles. You'll notice here that I'm at 1, 0, so obviously cosine is 1, sine is 0. Tan would be y divided by x, which would be 0 over 1, which is 0. Secant is the reciprocal of cosine, so cosine is 1, the reciprocal of which is 1. Cosecant is undefined because cosecant is the reciprocal of sine, so the reciprocal of 0 would be 1 over 0, which is undefined. Okay, and then the reciprocal of tangent is cotangent. And the way I want you to look at cotangent is I want you to, instead of going y divided by x, I want you to take x divided by y. So again, that's 1 over 0, which is undefined. Okay, and moving to the 90 degree or the pi over 2 angle measure, you can see cos is 0, sine is 1. This time tan takes its turn being undefined because y divided by x would be 1 over 0, undefined. Secant, the reciprocal of cosine, would be the reciprocal of 0, also undefined. And then cosecant A is 1 because the reciprocal of 1 is 1. Cotangent A this time is defined as 0 because x over y is 0. Right? And you sort of get the same thing happening at the other angles. I won't go through all of it, but you can take a look. You can pause this video and take a look at sort of some of the patterns there at the quadrantal angles. And that's it. So cast rule and some things to note about the quadrantal angles, as well as for not only the primary, but also the reciprocal ratios.